This is going to be a continuation for our lesson, okay, on the atom and periodic table, okay. So when you look at when you just look at the electronic configuration, it is important to note that, okay, we have, okay, for electronic configuration, the first shell, okay, they can occupy total of 2 electrons, okay, that is going to be the first shell. And the following shell, okay, can occupy maximum, okay, 8 electrons. And the following will be also 8, yeah. So you can see, okay, 2, 8, 8, okay. So this arrangement is called electronic configuration of atom. Okay, for example, okay, for this particular atom, okay, if the electronic configuration is 2, 8, 8. Now, this 2, 8, 8, okay, belongs to total electron is going to be 2 plus 8 plus 8, which is going to be 18. And this belongs to, okay, if you have 18 electrons, okay, can someone tell me this one belongs to what element? Okay, so maybe we can ask Kimberly. Okay, Kimberly, if you have 18 electrons, okay, it belongs to which element, Kimberly?
Argon.
Okay, argon, yeah. Because argon, okay, the proton number is going to be 18, okay. It means that, okay, the electron must be also 18. So argon, okay, it is written AR, okay, 18 at the bottom, okay, and then the 40 will be at the top. This is how you write. Okay, but if you look at your periodic table, it's going to be written in a different way. Yeah, please take note of that. So this 18, okay, is going to be your proton number is 18. Electron is also 18. So let's actually look at the number of neutron. Jesslyn. Okay, Jesslyn, what is the number of neutron over here for argon?
22.
Okay, so the number is going to be 22, yeah, 40 minus, okay, 18, okay, 22, okay. Now, I just want to maybe just ask another question also, maybe to, what is this and what is this, okay, 40, okay, Gabriel, 40, what is the name of the term that we use to represent 40, Gabriel?
The mass.
Okay, so it's going to be the mass number, okay, the mass number, okay, or, okay, it is also written as what? Albert, what number?
Nucleon.
Yes, okay, it is going to be known as nucleon number, okay, nucleon number. Now, how about this 18? Okay, 18 is going to be known as what? Okay, so maybe, okay, I will ask, okay, maybe Jake, can you tell me, Jake?
Atomic number.
Okay, atomic number. Or another name, maybe Brian, can you tell us? Again? Proton number. Okay, proton number. Okay, so if you put it, yeah, so I'll just make it smaller a bit. Okay, so please take note of this. Okay, now let's actually go back. Okay, so if you look at this, okay, the way that we put, okay, the electrons and so on, okay, we arrange the periodic table so that, okay, they follow according to group and period, okay. But the arrangement, okay, basically follows the proton number. You can see here, number 1, okay. If you look over here, number 1. Okay, you have number 1, followed by number 2, okay, followed by number 3, 4, 5, 6, 7, and you go on, okay, you go on. So it means that they are arranged according to the number of proton, okay. But when it comes to number of the mass number, okay, the mass number not exactly, okay, will follow. Like for example, you see here, 1, okay, then after that 4, okay, then after that 7, 9, okay, 11, 12, 14, 16. There is no proper trend, okay, when it comes to mass number. But what is certain, okay, the mass number is increasing. Okay, the mass number is increasing. So if they ask you, okay, in periodic table, it is arranged based on what? It is arranged based on the number of proton. Okay, number of proton. So when you look at the periodic table, okay, in the end, because we arrange according to the number of proton, which is the same as number of electron, you can see that, okay, group 1, okay, you will have 1 valence electron. Okay, you can see group 2, okay, this one is special, yeah. This one is group 8, okay, it's going to be 2 for helium only. Okay, but if you look at this, when you go to second period number 1, 1 shell, okay. Second period, 2 shells, okay, 2 shells, number 1, number 2, okay, 2 shells. And you can see that, okay, this is going to be 3 electron, you have like this. Okay, maximum first shell, 2 electrons, the another one is going to be 1. So this one is going to be the what we call as valence electron. Okay, this valence electron is going to tell us about, okay, they are going to tell us about two things, okay. One is going to be valence electron is going to tell us that it belongs to the group number 1, okay, like for example, valence number 1, okay, number 1, okay, you can see number 1, all of them belongs to group number 1. Okay, that is valence electron going to tell us about the group. And any elements in the same group, okay, they will have similar chemical property. Okay, similar chemical property. If they ask you why they have similar chemical properties, because, okay, whenever we are talking about chemical reaction, they are going to be involving electrons, okay? And if you have 1 electron, okay, 1 valence electron, it means that all of them are going to react the same way, okay, the same way. So the same thing goes to group 2. You can see this is group 2. You can see the valence electron is going to be 2. Okay, so group 2, they have their own chemical property. Group 3, valence electron, okay, they have the same chemical property, okay. Now, I just want to ask a question on this, yeah, Cl, okay. Now, for Henrietta, for Cl, can you tell me, okay, Cl is going to be in which group and which period? By just looking at this number. Right, Henrietta, group number. Or if I guide you, okay, Henrietta, this is going to be, what is the valence electron over here for Cl? 7, yeah. I'm not sure, it's not so clear, yeah, to me. Yeah, it's supposed to be 7, yeah, you can see 7. So this one is going to be group 7, okay, group 7. And period number what? Okay, maybe I will call max. Okay, what is the number of period? Max, are you here? Yeah.
3.
Period number 3, correct. Yeah, because why? You have 1 shell, 2 shells, and 3 shells. Okay, so you have 3 shells over there. It means this is going to be, okay, period number 3. Period number 3. Okay, you don't just simply look over here. Yeah. So you just need to look at the shell over there. Okay. Now, so it tells us, okay, a lot of things. Okay. Now I'll just test you guys. Okay. You can see maybe, okay, let's ask you about oxygen. Okay, oxygen. Now, you can use whatever way that you want, or maybe better, yeah, if I just take it out, yeah, oxygen, 8 and 16, okay? So for oxygen, okay, Naomi, can you tell me what is the number of proton, electron, and neutron?
8 proton, 8 electron, and 8 neutron.
Yeah, okay, correct. Okay, and then Cheryl, can you tell me if I want to write the electronic configuration for oxygen, how do I write?
2 and 6.
Okay, 2, 6. Okay, now from this value, okay, 2, 6. Okay, can Terrace tell me, okay, what is going to be the period number? Okay, we will wait for you, Terrace.
Is it two, sir? This one I'm not too sure.
Okay, period is the number of shells. Okay, you can see. Okay, there are 2 shells over here. Okay, so it is 2, period number 2. Okay, period number 2. You just need to look at the 2 shells over here. Yeah, so period number 2. And then if you are looking at group, okay, for group, we look at the valence electron. So Jesse, can you tell me what is the valence electron for oxygen?
6.
Okay, so valence electron is 6. So this belongs to group number? Okay, maybe I'll ask Elvina.
6.
Okay, Jesse already answered. Yeah, so group number 6. Okay, so this one, okay, if I want to actually put it back over here, you can see period number 2, okay, period number 2, and group number 6. Okay, group number 6, period number 2. So it belongs to oxygen. Okay, so something like that. Okay, now I will just move on. Okay, so now, okay, if you look at the patterns in the periodic table, okay, the period number, okay, shows how many electron shell, okay, like what we have done just now. Group number, okay, is the same as the number of outer shell electrons, which is, I use the term valence electron. Okay, valence electron. So the atom of group 1, okay, they have, okay, one outer shell electron. Okay, group 2 has 2, 3, and so on. Okay, like for example now, okay, I just want to check, yeah, phosphorus. Okay, if I just ask you, okay, how many valence electron phosphorus has? Michelle C. Okay, can you tell us how many valence electron phosphorus has? Okay, we will wait for Michelle C. Oh, Michelle is having internet issue. Yeah, wait. There are 2 Michelle over here, so I will ask Michelle Chan. Michelle, the Michelle which is here, Michelle Chandra. Yeah. Okay, Michelle, please unmute. What happened, Michelle? Michelle Chandra, maybe internet issue here, Michelle. But I can see Michelle there. At least, Michelle, you can actually reply me through WhatsApp or you can chat. Okay, that's nothing. I'll give you another one more chance, yeah, Michelle. Yeah, if not, then I will kick you out from the meeting. Now, Max, tell me what is going to be the valence electron, okay, for phosphorus.
16.
16. Why? Valence electron. Just look at the group. Okay, what is the number of the group over here? What is this number? 5. So the valence electron is 5. Okay, from where we get this? Okay, phosphorus is 15. So it's written 285. Okay, so this is the valence electron. So 5. Okay, so the valence electron is 5 and it belongs to group number 5. Okay, so Maxwell, if period, our period, phosphorus in which period? One, two, three. Okay, period number 3. Can Max? Okay, so this one you can just see from here. Okay, 3 because it has 3 shells. 1 shell, 2 shell, 3 shell. Okay, hopefully it's clear. Yeah. Now, so we also have what we call as the group 8, which is going to be known as the special group. The special group, which is going to be group 8, is going to have full shells of electron, and we call it as unreactive. So these are the group 8. When we look at group 8, all of them have 8 valence electron except for helium. Helium only has 2. Yeah. So this one, the valence electron is 2, but because they have the first shell, so the first shell is full, by maximum by 2 electrons. But if you look at neon, neon is going to be 2,8. If you look at argon, it's going to be 2,8 and 8. Okay, so in the end, the valence electron is going to be 8. Okay, that's why they call it group 8. Okay, but because of the valence shell, the last shell, the outermost shell is complete with the electron. Okay, there is no electron going out. There is no electron coming in. Therefore, we call it as noble gases because generally all these groups, they are gases, and they are going to be unreactive. Like for example, one example is helium. They say helium is a very light gas. It is ideal for filling up balloons. So the other group 8 elements are also gases. Therefore, the special name that is given to group 8 gases, or group 8 elements are, we call them as noble gases. Noble gases are generally gases that are unreactive. That are unreactive, or unreactive, there is another word that we use, which is going to be, we call inert. Inert means unreactive. Unreactive. Now, if we move on further, this one, we have done, a bit, so if you can see here, like for example, 6b, what can you say about the chemical reactivity of krypton? So if you look at the chemical reactivity of krypton, krypton is here, you can see it's under group 8, So krypton, if they ask you about the chemical reactivity, what do you answer? Albert, what do you answer? It is in group 8. Therefore, Therefore what? Albert.
It is noble.
It is noble. Noble is the name. Okay. It's a noble gas. Is actually the name. But you need to tell about the chemical reactivity. So therefore it is unreactive. Don't give their name. Yeah. You just tell it is in group 8. Therefore it is unreactive. Okay, what else? The name that they call, yeah, unreactive gases. We call it as noble gases or inert gases. Yeah. So this one, you just need to tell unreactive. Why unreactive? Because I told you whenever it comes to chemical reaction, okay, chemical reaction involves electron. Okay, it means that electron, okay, needs to be lost or electron needs to be accepted. Okay, in this case, because it's group 8, the last shell, okay, the outermost shell has 8 electrons. There is no need for the electrons to go away. There is no need for the electron to come in. Okay, there is no way that thing can happen. Okay, because it's all complete. So if it is all complete, okay, it means that we call it as unreactive. Yeah. So this is going to be up to there. Yeah. So today's lesson, okay, I will stop recording now.